unfold.
All right, welcome to The Explainer. Today, we're jumping right into a really critical situation. We're talking about the Thwaites Glacier in Antarctica. And look, this isn't just some far-off chunk of ice for scientists to worry about anymore. It's become maybe the most important factor for our planet's stability in the very near future. Now get this quote, and to be super clear, those aren't my words. That's the chilling conclusion from the latest scientific fieldwork. The so-called Doomsday Glacier isn't a ticking time bomb anymore. It sounds like the fuse is lit and burning. Okay, so what are we talking about here? Well, Thwaites is this enormous glacier in West Antarctica. I mean, to give you a sense of scale, it's about the size of Florida. But it's not the size that's the scariest part. It's why it got that terrifying nickname that we really, really need to dig into. Yeah, this is way past just melting ice. The newest data is telling us that the glacier itself is structurally failing. The whole story has changed. We've gone from thinking about a slow melt, a thermal process, to a rapid mechanical shattering. It's like we're watching a giant break apart in real time. So to really get why this is such a big deal, we gotta pop the hood and look at the physics of Thwaites itself. And it's terrifying, frankly. It's not just that it's huge. It's almost like it was designed to fail in the worst possible way. Think of it like this. Thwaites is basically the cork in a giant bottle, and that bottle is the entire West Antarctic Ice Sheet. If that one cork comes out, well, you're looking at a potentially unstoppable flow of ice from way inside the continent just pouring into the ocean. And just look at these numbers. They really paint a picture of its insane scale and its biggest weakness. See that part about the bedrock, a retrograde slope? That's the real killer here. It means the farther back the glacier melts, the deeper the ground beneath it gets. So warm ocean water can just get in there and attack more and more of the ice, making everything happen even faster. It's a vicious cycle. Right, so the bottom line is this. The actual geography, the shape of the land under the ice, basically guarantees that once this thing starts, it's just going to get faster and faster on its own. Thwaites is like the perfect poster child for this kind of runaway collapse. Okay, so now let's get to the really new stuff. The findings from the last couple of years, 2024 and 2025. This is where things get really urgent. This research has completely flipped our understanding of how this glacier is actually falling apart. And this is a huge change in thinking. It's not just about the glacier thinning out from below anymore. No, the entire structure is getting wrecked. It's literally shattering, like a car windshield when it gets hit by a rock. It's a mechanical failure, not just a slow melt. Scientists have a name for this, a 20-year fracture cascade. So here's how it works. First, the ice thins out and loses its grip on a really important spot on the seafloor that was holding it in place. Once that friction is gone, the whole thing speeds up. That acceleration stretches the ice, which creates even more cracks, which weakens it further. The very thing that used to be its anchor is now the reason it's tearing itself apart. So to figure out what was going on under the ice, researchers sent this amazing robot submarine called Icefin down through a hole they drilled. And what it found wasn't a nice, smooth underside. It was this crazy, chaotic landscape. Warm ocean water is just shooting into these giant crevasses from below, making them wider and pushing those cracks all the way up through the entire glacier. And listen to this. This is what it actually sounds like to be there. Researchers on the ice can literally hear the glacier dying around them. They describe it as cannon shots or thunder. Can you imagine? It's this constant, terrifying reminder that the very ground they're standing on is breaking up. Okay, so you might be thinking, this is a giant glacier thousands of miles away. Why does it matter to me? Well, the reason it matters is because the consequences of this, they're global, and there's really no escaping them. Let's start with this number, 65 centimeters. That's about 2 feet. That's how much sea levels could rise, on average, around the world, just from Thwaites, all by itself. But remember that whole cork in the bottle thing? If Thwaites goes, it's probably going to trigger the collapse of the entire West Antarctic ice sheet behind it. And if that happens, you're looking at this number, 3.3 meters. That's over 10 feet of sea level rise globally. That's a world-changing number. And here's where it gets even weirder, kind of counterintuitive. The impact isn't the same everywhere. See, an ice sheet that big has its own gravity, and it pulls the ocean towards it. As it melts, that gravitational pull gets weaker, and the water basically sloshes away. And where does a lot of it go? To the northern hemisphere. So cities in North America and Europe could actually see more than 10 feet of sea level rise. Let's make this real. Take London, for example. The city depends on this huge flood barrier, the Thames Barrier, to keep it safe. The problem is, it was designed using climate models that are now completely, hopelessly out of date. And this chart just lays it bare. It was designed to be closed maybe 2 or 3 times a year. In one recent winter, they had to close it 50 times. It's already being pushed to its breaking point decades before anyone thought it would be. If Thwaites goes, that barrier becomes basically useless. Or look at New York City. Even with the conservative numbers we have now, more than a third of the buildings in Lower Manhattan are at risk from storm surges by 2050. Now imagine adding 10 feet of sea level rise on top of that. What is now a temporary storm risk becomes a permanent flood. And then there's Shanghai. It's the busiest port in the world, and it's already on a sinking river delta. The outcome there is just catastrophic. We're talking about a scenario where the city could be completely gone, and you'd have to move, 17.5 million people? It's almost unimaginable. So when the stakes get this high, the whole conversation changes. And that's what's happened. Scientists are moving on from just watching and studying the problem. Now the big question is, can we actually do something to stop it? And the ideas on the table are wild. I mean, stuff that would have been pure science fiction 10 years ago. You've got one idea for a gigantic underwater curtain to physically block warm water from getting to the glacier. Another is to pump a wall of air bubbles up from the seabed to disrupt the warm water. Both of these are, let's be honest, desperate Hail Marys. It's like trying to perform surgery on the entire planet. But you can't just go and do something like that without thinking about the risks, and they are massive. First, is it even legal? Geoengineering is in this total gray area. Second, what would it do to the ecosystem? You could collapse the entire marine food web down there. And third, there's the moral question. If we try for some crazy techno fix, does that just let us off the hook for dealing with the real problem, which is cutting our carbon emissions? Which brings us to this final, pretty heavy thought. The science is crystal clear. The map of the world that we know today is not what the map is going to look like in 2100. Our coastlines will be redrawn. The only question left is who's going to do the redrawing. Will it be the ice or will it be us?